Yes, there is a one more important note. There is rectifier and inverter. Rectifier means which converting AC to DC, means alternate current to direct current. Inverter means which is converting direct current to alternate current. This is the two important note. We are coming for, I told you there is a problem based on the electric current. I'll just read out the question and I'll say you how to analyze the question. The current in a wires varies with the time. So you are seeing that varies with the time, then obviously it is instantaneous current. We are coming for steady current. I is equals to Q by T. This is about the steady current, but they have mentioned it is varying with the time, then obviously it is not a steady current. So your formula is I is equals to dq by dt. It varies with the time. According to the equation, I is equals to 4 plus t to 2t. So they have given one equation how it is going to vary. Next, the quantity of the charge which has been passes through cross section area is 2 is equals to time is equals to 2 seconds to 6 seconds. I mean, we need to calculate how many number of charges, how many quantities of charges is passed in that cross-sectional area in the time 2 second to 6 second. So we have written the solution. We have written I is equals to dq by dt. Now I need to find what is the quantity of charges which is flowing in the cross-sectional area. So you just cross multiply this. dq is equals to I into dt, where here I am just integrating both the side. I am integrating both the side, even here and here. See, you have dq integration. So I'll just say you the simple thing why we are writing the q. Something we'll go for related to the mathematics which make you an easy thing. Think integration is x, differentiation is always reciprocal of it. So 1 by x. So if it cancel, it will be remaining q. So it's a simple method to why integration of dq will be equals to q by using a mathematics. This will be equals to then again integration of I into dt, where I is the current, dt is the change in time. Now there should be some limit when we are doing the integration. So how does from where to where we are finding the charges is flowing in which time? They have already given from 2 seconds to 6 seconds. So write it from 2 seconds to 6. That will be your limit. Next, you know what is height because already they have given. I is equals to 4 plus 2t. Right, in the place of I you can write 4 plus 2t dt, where we know well in integration how to do it. So we can integrate it. 4 is just a constant, 4 into t plus 2 is a constant. We are coming for t, the integration t square by 2 get cancelled, apply the limit. So you will be getting 4 into 6 plus 6 square, upper limit minus lower limit, minus 4 into 2 square is nothing but 4. So 24 plus 36 minus 8 plus 4. So you will be getting 16 minus 12, 48 coulombs. So this is about the charge, how much charge will be flowing in that area while time from 2 seconds to 4 seconds. This is a problem. See, there is some bit variation. They can do changes and they can give the current and they can give the time. What you can do, this is if they give current and time, this is the method you will follow. Suppose if they given the charge, if they given the time, we need to differentiate. If they given there you will be using differentiation. Now we have used the integration, there you will be using the differentiation. You need to solve that differentiation with respect to time. So example, if you take q is equals to 4t square plus t. So just a differentiation, dq by dt, that is 8t plus 1. This will be your I. If they are given the time value, just substitute there. If the time is 2 seconds, so 2 plus 1, 16 plus 1, 7 ampere. Now this is what a simple thing. If they change and they give you the same formula will be there, but you should check whether it is current is varying or it is steady current. Next, one more problem. Two boys A and B are sitting at the 2 points. In the field, both the boys are sitting in the resemblance of the charge ball, each carrying the 3 electrons. A will be throwing 100 balls, where B will be throwing 50 balls. Find the current between the midpoint of C. This is a very simple problem. See, from the A, he will be throwing the 100 charge balls. Means each charge will be considering 3 electrons. So 100 into 3, you will be getting 300 electrons. We are coming for B, that is I2, he will be throwing 50 into 3 electrons. See, a simple thing, the same thing, they have compared with the 2 person. So the person is throwing a charge ball, something that charge is flowing, obviously it is current. So they have just given like a applied question, so where you can imagine it and you can analyze it. So a simple thing, you should think and you should analyze it. So 50 into 3, 150 electrons. Now from A to B, if the C means C5, net force will be minus of it. So 300 electron minus 150 electrons, it gives you 150 electrons. Substitute the electron value. Electron value is 1.6 into 10 to the power of minus 19 coulomb. So 150 into 1.6 into 10 to the power of minus 19 will gives you 2.4 into 10 to the power of minus 17. This will be your final answer. Next, we will be discussing about current density. What exactly is current density? See, current density is nothing but how much current is flowing in that particular cross-sectional area. That is nothing but your current density. How much current will be flowing in that particular cross-sectional area? That is nothing but your current density. See, where I is equals to J into A. So J is nothing but your current density. J will be representing the current density. How much current will be flowing in cross-sectional area? That is said to be current density. Next, drift velocity. It's an important topic and interesting topic. Where drift velocity, see, usually before giving the battery, the conductors, the charges will be moving with its own speed and it will be having its own velocity and fine. We will check whether the velocity is there or not. So, but we know that, so the charge will be in the motion. See, when you are considering without battery connection or anything, if you consider just a conductor, so the charge will be moving in a different direction. So, different direction. So it is covering a distance. So charge is moving. Obviously the charge is moving. It is covering the distance. But it will come, suppose if the charge come back to the same position, what about the displacement? It will be 0. So obviously your velocity, initial velocity will be 0 because there is no displacement. But it is covering a distance, means which is having particular speed. So what happens, it will be having particular speed, it will be moving, and even the collision also may take place when they are moving. Obviously when they are moving in a different directions and it goes like anything, there will be a collision taken place. So there again we will be studying detailedly out when the collision is taking place, what will be the happen, and even by passing the electric field. Means when I give a battery, so that is nothing but you can see we can pass the electric field. What happens when we pass the electric field? By using that electric field, it drift or it will changes its direction. It will drift because of the influence of electric field. So the velocity will be changed. So the velocity of the electron will be changed. That is nothing but your drift velocity. So the drift velocity will be having the value. So approximately we will be considering the value 10 to the power of minus 4 meter per second. Suppose now we will consider dq. We will consider dq. dq means what? A charge, a small charge. We are considering in overall conductor, we are considering a few charge. So when I am considering the charge, the first, if I am considering a classroom, first thing how many number of students, correct? So n number of students. So now here I am going to consider n number of electrons. So n number of electrons with respect to per unit volume. N number of electrons per unit volume you are going to consider as a n. So n, what I am considering? Electron. I need to write it. So dq means with respect to cross-sectional area. So I am going to consider the number of electrons in that particular cross-sectional area. A is again important. Yeah. Now we will just consider a conductor. This is a conductor. So this will be a particular length, or I can say it as, or even I can write it as delta x. Even I can write it as delta x. Suppose the few charges, dq charges only is flowing with respect to time dt. The flow, so the flow of electrons is taking, or the charge is flowing with respect to the cross-sectional area with the time of dt. See, if you consider this direction, all these charges, or this cross-sectional, all these charges, they will move in the same time. All that cross-sectional area, whatever the charges is there, they are going uniformly. Now, so we know that velocity is equals to displacement by time taken. Displacement by time taken. Here I am not considering only one single electrons, I am considering average velocity of the electron. I am going to consider average velocity of an electron which is influenced by the electric field, or even I can say it's a drift velocity. Even I can say it is a drift velocity. So Vd is equals to delta x by time taken. So if I cross multiply, delta x is equals to Vd into t. So even the charge is flowing through this particular distance or displacement, so I can write it as, in the place of delta x, I can write it as Vd into t. Vd into t. Now we know that dq by dt, or even you can write dt there. So if it is a steady current, you will be writing t, or if it is a not steady current, if it is varying, you will be writing dt. Simple. So substitute NEA Vd into dt by dt. This get cancelled, so your I equals to NEA Vd. Here you have a drift velocity, area of cross section, electrons. N is the number of electrons per unit volume. This is about the drift velocity. Thank you.